in technical speaking or chemical engineering point of view, it's a chemical reaction involving rapid oxidization of fuel, burning of fuel. So we call it is an exothermic reaction because it releases heat. What is more important for us in this general discussion is this what is called fire triangle, where you need three ingredients to create fire. One is oxygen, as one of your colleagues said, and that is other one is the food, that is fuel. And the third one is you have to provide some heat. So when you have these three things available at the same time, you could expect a fire. So that is what is meant by fire triangle. Fuel, oxygen, and heat leads to a chemical reaction. Now, so all these three ingredients are required to create a fire. Now, we talk about not creating fire, but suppressing fire. So in order to suppress fire, what we could do? In fact, we need all these three components to start a fire. So if you can take out at least one of them, you can suppress the fire. So you don't have to take all three out, but at least one, if you take out, then you can suppress fire. So either you'll have to take out oxygen supply, or you'll have to take out heat supply, or you'll have to take out fuel. So the taking the fuel out is quite tough ask, so it is difficult. Therefore, usually what we do is either we take out oxygen or heat. Now we throw water at whatever the fire, so that means we are going to take the heat out. And sometimes we throw sand to the fire so that we can block the oxygen supply to the fuel or the burning elements. So we take out oxygen supply, therefore we can suppress fire. So I hope you have seen that these sand buckets are hung in petrol stations. So our objective in case of suppressing fire is to take out one of them. So mostly either heat or oxygen supply. So all this lecture series is about the techniques that we could use to do that, and methodical procedures that we need to follow in order to do it in a more scientific manner. So that is basically what we are going to talk today. Now, before going to looking at various different methods and methodologies available for us to suppress fires. Now, the fire usually has 4 phases. The initial phase is the ignition phase, where the initiation or inception of the fire takes place. For that, as we just mentioned, fuel, heat, and oxygen should be present. And the fuel is needed to be heated to a certain level, which is beyond its ignition, self-ignition temperature. So you'll have to ignite the whatever fuel, you have to bring the temperature of that fuel beyond its self-ignition temperature. So that is where the heat comes to play. And initial phase and ignition, and then the fire growth phase. So once the fire starts in a small area, it grows quite rapidly, initially quite slowly, but then again it grows quite fast. So this when things are heated up, then the air density goes down, and accordingly the convection draws more air into the fireplace, so that encourages the rapid growth of the fire. Third phase is the development phase. So where this heat production will be at maximum, and the oxygen will become consumed rapidly, and there will be a rapid fire everywhere catches fire and that is kind of an uncontrollable situation. And then lastly, the fire decays off with the exhaustion of fuel or anything. That would be the end of fire. And if you look at these phases in a diagram, so this is the increase of temperature, mass loss rate, and heat release rate. Whatever these things are quite slowly increased in the initial phase, and then the ignition takes place, and then there's a faster growth up to a certain point in the development phase. There's a point called flashover point, and then I'll come to that later. And then there's a fully developed fire you see, and then after some time, the fire will run out of fuel. Accordingly, once everything is burned, accordingly, it will decay, and that will be the end of fire. So there is a special level in this process, which is called flashover point. So that is very important, because if you want to suppress a fire, you'll have to do it before the fire goes to the level of flashover point. So this is kind of a time scale. So whenever you want to suppress fire, you'll have to do it before it goes to the flashover level or time. So beyond flashover, you will never be able to control or suppress any fire. So you'll have to act fast. Whenever you see a fire, you'll have to act fast before it grows beyond the flashover point. We'll have to do the necessary protective action to suppress fire. And at the same time, earlier the better, because with the time, a lot of distractions take place. So earlier the better, but if you it has to be before flashover point in order to suppress fire. So we have limited time in order to suppress any fire. So so that is the flashover. So that is what I just said. Now, when it comes to structural fire protection, so there are two ways of protecting fire. One is the passive fire protection, and the other one is active fire protection. The passive fire protection is mostly the things that we install. It can be a wall, or it can be a fire door, or anything like that. So those do not need any attention, either automatic operation or people's involvement. So they are passive things. So we consider about certain things, and we, for example, fire door is a passive fire protection system. So that will at least confine the fire to a certain room or something like that, and it keeps the fire grows beyond that fire door. So the fire doors are also designed to sustain at least for 30 minutes for the same reason I said. And active fire protection systems, where it can be automatic systems or it can be manual systems, where you do some activities to suppress fire. So we have two systems, active systems and passive systems. Passive systems are more or less like walls, fire doors, and things like those, which are structural elements installed in the system, in the building. So those will prevent the growth of the fire beyond a certain area. And the active systems, of course, you have manual or automatic detection and protection systems. So those need to be controlled externally, either manually or other means like automatic operation, things like that. Now, in a total fire protection system, so we have many systems, separate systems we could identify. One is to take out heat. We can have a sprinkler system to spray water all across. and we can have detection and alarm system. Whenever you detect a fire, then it can be a manual detection or it can be automatic detection, and then it gives us an alarm so that people in the building can be evacuated. They can simply run out of the building, and the firefighters or same occupants could use certain fire protection systems to suppress the fire. For that, certain suppression systems are there. For example, portable fire extinguishers, and fire hydrant systems, etc. So we are going to discuss about those techniques. And then there are certain smoke and fire dampers, so to restrict the growth, like the fire doors and things like that. And then you can have fire walls, fire floors, and you can use fire rated cables for electrical supplies, etc. So, and then you can have a kind of a fire education system, so that people or the occupants of that building could be educated enough to act fast whenever they see fire, and like that. So there are many subsystems that are included in structural fire protection and detection system. The main components of a fire detection and alarm system are smoke alarms, heat alarms, sounders to make people aware of such a fire, and exit signs to guide people to go out of the space as soon as possible. And then fire protection suppression system. Under that, we can have portable fire extinguishers, fire hydrant systems, and sprinkler systems. So the hydrant is water. So you can have hoses and things like that, where you can throw water at the fire. And the sprinkler system is an automatic spraying system. I hope you have seen, at least some of you have seen sprinklers. So nowadays, these systems are there in supermarkets also. You can see these fire protection systems. So those are the key elements in fire protection system: portable fire extinguishers, hydrant system, sprinkler system. And there has to be, again, a building management system, we usually call BMS. So nowadays, these modern buildings are, equipped with a centralized control system called building management system, where your fire system, air conditioning system, lighting system, maybe storage and other supply systems are controlled using a central microprocessor-based system, which is called building management system. So the connection of all these components together is very important. For example, whenever there is a fire, then these modern buildings, they shut down air supply, air handling units of air conditioning systems, for example, so that the air supplies and the fire going through these ducts and entering different compartments can be restricted and things like that. So it is very important to have integrated systems like that. So in most modern buildings, we have this building management system, which integrates all subsystems of buildings, not only fire detection protection system, but also other systems like air conditioning and various other lighting systems and things like that are interconnected and centrally controlled. So those are the main elements we find in fire detection protection systems. So now in this course, of course, we are not going to go into the depth of each and every aspect of this fire detection protection, but I will try to give you a brief overview on the importance of these systems and some design requirements and procedures about designing fire detection and protection system for buildings. When you want to put up buildings, then you have to meet certain requirements. If it is an urban building, requirements of municipal council and requirements of urban development authority or whatever these, there are various different authorized bodies, and we need to meet their certain requirements. So depending upon the location of the building and the size of the building, these organizations list out the requirements that are needed in the fire protection and detection systems in a particular building. For example, if it's a high-rise building in a municipal area, so the municipal council gives you their requirements, what kind of fire systems are required for that. If it is a small building, like a couple of two-story building or something like that, depending upon for what purpose you use that building, then there will be certain requirements. In simple speaking, for some buildings, you don't need fire hydrant systems, only portable fire extinguishers would be enough. Sprinkler systems are not required, or fire hydrant systems are not required. But for certain buildings, you need all these 3-4 systems integrated together. So, so in order to design a fire safety system, we usually follow certain international standards, like in any other design exercises. So usually for fire system design, we use British standards, BS codes. So these are some of the BS codes that can be used for different design of different systems. For example, this BS 9999 is for design management, safety in design management and use of buildings. And 5839 gives us fire detection and fire alarm system design for buildings. And 5306 tells us about the fire extinguishers and so forth. And that is the British standard. And for mechanical related systems, heat and air conditioning system or fire systems or things like that, there's a greater tendency to use American standards than Euro and British standards. But of course, in Sri Lanka, we use Euro standards also. And there's British Euro combined standards for fire systems. But these American standards are also frequently used. For example, air conditioning design, usually we use ASHRAE code, that is American. And fire systems also, quite frequently we use NFPA codes, National Fire Protection Association, which is again an American system. So similarly, BS code, this NFPA also gives us various guidelines and design requirements and design procedures on various different subsystems of fire protection systems. So NFPA 72, 25, 10, 13, etc., available for that. And as I said earlier, we refer to Euro standards, BSPN standards, and also we have to meet the requirements of the fire service department, that is more or less the fire brigade in the municipal area or any local authority. And then again, ICTAD also stated some regulations for designing and requirements rather for fire safety systems. So we have to meet these ICTAD regulations also. So these ICTAD regulations are mostly extracted from these fire codes, either British or American or whatever. These ICTAD regulations are extract from these fire codes. I have given you sort of a sample of ICTAD regulations. I have uploaded that in the web page. And one example of fire service department requirement also I have uploaded. And this BSEN code is also uploaded just for your information. So if you're interested, you can explore these things. And the fire load of the building. Now, when it comes to design of the fire detection and protection system, one of the key things that we need to understand or identify is the fire load of that building or the compartment. The fire load is mostly the potential severity of a hypothetical fire that gives us an indication about the likelihood of catching fire. For example, if you store fuel, petrol in a building, so that the fire load is very large. And if you have only wood in that building, the fire load is comparatively low. Like that, depending upon what you have in the building, we can estimate the fire load. So it is the heat output per unit flow area, that is in terms of kilojoules per square meter. Heat output per unit flow area is what is meant by fire load. So it is calculated based on the calorific value of the material. So that is the heating capacity of the material. So zero fire load is more or less, if you don't have anything which catches fire, it's zero fire load, and anything any additives could catch fire. So that adds the fire load. So these codes and other handbooks provide us the calorific value and the total fire load of different material that you store. So depending upon different type of materials you store in a particular building, you could calculate the fire load. So those information are available in fire codes and handbooks. Now that estimation of fire load is more or less either quantitatively or qualitatively is one of the starting points of design of a fire protection system, because you have to evaluate or estimate the fire hazard level of a particular building in order to do the design. The fire load of that building. There's fire resistant rating for mostly for passive fire protection equipment or devices like fire walls and brick walls and fire doors, etc. There is a fire resistant rating. So this rating, as you can see here, the block wall load bearing, the fire resistant rating is 4 hours. So it can stand for 4 hours. So we will have to suppress fire within 4 hours. If you want to suppress the fire going beyond that wall, something like that. And so those are just I'm just giving you a bit of a overview on these different things. As I said earlier, we are not going to go into the depth of all these things, but just to get an overall idea of the fire detection systems, I'm just presenting these things. Now, as I said earlier, based on the fire load of a particular building, we need to identify the hazard class of that building in order to start the design of fire suppression system. So there are, for example, according to Euro standards, EN standards, it has light hazard, ordinary hazard, high hazard. An ordinary hazard is divided into further 4 groups, group 1, group 2, 3, and 4. And the high hazard is again divided into 2 sections. Now, if you go to the code, I will just show you now, for example, in this annexure A, the classification of type of typical hazards. So this is the hazard level, the light hazard occupancies, schools and other educational institute, offices, prisons. So this code tells us, depending upon the nature of the building, what the hazard group it is. For example, for ordinary hazard, chemical industry, for cement works, ordinary hazard 1, photographic and film factories, ordinary hazard 2, glass factories, ordinary hazard 3, like that. They have identified different types of activities that we do in buildings, and accordingly they tell us what is the hazard group or hazard level of that building. For example, if it is a office building, usually it is ordinary hazard 3. shop and office buildings, department stores, shopping centers. So that is ordinary hazard 3. Likewise, if it is something dealing with paper, book binding factories, cardboard factories, paper factories, and things like that, it is ordinary hazard 3. And there are things of ordinary hazard 4. Like that, the hazard class has been listed in these codes with examples like this. So sometimes if you want to do a real depth analysis on this hazard level, then you'll have to do a good calculation about the fire load of that particular building. And based on that, you can initiate your design. So in a design exercise, the first thing is to identify the hazard class. Now, once the fire hazard class is identified, so you need to have an idea of for what purpose this building is going to be used. It can be multi-purposes, like you can have a basement car park, for example, and an office somewhere up, and there can be some restaurants, food courts, and things like that. So it can be different class of hazards at different levels of the building that can happen. Now, usually this fire service department requirements are based on this hazard level. So this municipal council tells you, depending upon the hazard level, hazard class of the building, what kind of systems are required. Now, if I go to this thing, so this is again, it's not very clear though, but something from the fire service department requirement. So you could get a copy of this from the fire brigade, fire service department of the municipal council, for example. Now it says, for example, if it is a light hazard situation for a building, non-riser building, floor area exceeding up to 800 square meters and up to 18 meters in height. So this is the limit that they say. And if it is a light hazard, these are the things that you need. You have to have a fire extinguisher for every 210 square meters of area. And you have to have a fire aid hose reel every 800 meter square area. And you have to have exit signs and alternative means of escapes and manual fire alarm system. So if the building is a non-riser building and the floor area is up to 800 square meters. But if it is, for example, if it is a high-rise building, with a height of 30 meters to 45 meters, and if it is a medium hazard or ordinary hazard level, then you have to have extinguishers, hose reels, wet risers, manual fire alarm system, automatic fire alarm systems, automatic sprinkler systems, auto flooding systems, alternative means of escape, and pressurized stairways, and many things. So depending upon the ordinary hazard level or the hazard class of that building and the requirements of the fire service department, you can start your design. So you can identify what type of components are required in your system, and then accordingly you can do the design. So that is how the fire systems are designed. So you identify the hazard class, and then identify the requirements, what kind of subsystems are required, and then according to the international standards and codes of practice, we can design each and every subsystem. Now, in a fire safety system, we in fact don't identify the entire building as one fire safety design system. So one of the elementary things that we do is we identify fire zones. The codes itself give us some guideline to how to identify fire zones. So we implement our fire system, a protection system, in terms of fire zones. one advantage of one straightforward advantage of identifying or clustering the building into different fire zones is now if there is a fire breaks out in a particular area in the building, and let's just think of a high-rise building, and in a small area somewhere there is a fire. So the fire detection system would detect and tell us there is a fire in zone 3. Then immediately we could get an idea about where this fire is. Now, if entire building is one single zone, then you will find it difficult to locate where the fire is and then reach that place as quickly as possible. So basic requirement of dividing or segmenting a building into different fire zones is to identify where the fire is and attend to that as quickly as possible. So the code say the maximum size in one zone should be 2100 rather square meters. So and maximum number of water flow switches in one zone should be 5. We'll come to this water flow switches and things like that when we talk about hydrant systems. And number of supervisory devices in one zone is 20. That means fire detection devices and things like that. So the fire codes clearly give some guideline for us to identify our fire zones. So according to these guidelines, we have to cluster the building area into different fire zones. So one key importance of this, as I just mentioned, is to quickly identify where the fire is, accordingly to attend to it as quickly as possible.